Okay, so the final type of energy we're going to look at where we need to know the equation is thermal energy. So we can actually see how energy changes within a system or an object when the temperature changes by calculating the thermal energy, well, that's actually within the system or the object. And so over here, we've got the change in thermal energy. So this is what we call the thermal energy. And the equation for it is as follows. It's m times c times by delta theta. So what do each of those mean? Well, m we should be used to by now, that is the mass. C is what we call the specific heat capacity, and I'll just write SHT, but it's the specific heat capacity, and delta theta is the change in temperature. So that delta symbol basically means when we're looking at the change in something, but theta itself refers to the temperature. And so let's actually put some units on first, and then we'll go into what each of those means. So the thermal energy is in joules as a form of energy. The mass is in kilograms as usual. The change in temperature is in degrees Celsius. Even though it's still a change, the unit is still degrees Celsius. And finally, the specific heat capacity, which we'll talk about now, is measured in joules per kilogram degrees Celsius. So now let's actually have a look at what we mean when we say the specific heat capacity. So we can just define this very simply. The specific heat capacity of a substance is the amount of energy required or needed to raise the temperature of 1 kilogram of the substance by 1 degree Celsius. Okay, so it's quite a mouthful, but essentially all we're saying is that any type of material will have its own specific heat capacity, and what that means is every different type of material will require a different amount of energy to input to make sure that that material raises temperature by 1 degree Celsius. And the reason why specific heat capacity is we're talking only about 1 kilogram of the substance. Obviously, if you have more of the substance, then it will take more energy. So to standardize it, we're saying that whatever material you have, if you were to have 1 kilogram of that, and you wanted to raise the temperature of 1 kilogram of that material by 1 degree Celsius, then the specific heat capacity is the amount of energy that you would need to do that. Okay, so hopefully that makes sense. And essentially that is your equation here, that's what you're dealing with. And so let's go ahead and do a quick example question to see what we understand. Okay, so here's your question. Pause the video to have a go. 5,000 joules of energy was used to increase the temperature of 12 kilograms of a material from 10 degrees Celsius to 30 degrees Celsius. What is the specific heat capacity of the material? Pause the video, have a go. Let's go through the answer now. So we have our formula that we write down here. So the change in thermal energy will be equal to the mass multiplied by the specific heat capacity C multiplied by delta theta. And so we can just take our numbers from our question here. So we've got 5,000 joules of energy. So the change in thermal energy was 5,000. That was the energy that was inputted into the material. And that's going to be equal to the mass of the material, which was 12 kilograms, multiplied by the specific heat capacity, which we don't know, multiplied by delta theta. Delta theta is a change in temperature. So to work out the change in temperature, then we will just do the starting temperature or the finishing temperature, the final temperature, minus the starting temperature, which is 30 minus 10. It's in degrees Celsius, so we don't need to convert anything. So we get a change in temperature of 20. So delta theta is going to be 20. And then all we need to do now is rearrange for C. So C will equal 5,000 divided by 12 times by 20. So divided by 12 divided by 20 if you like. And so we can work out the specific capacity then if we just put that into our calculator. And you should get a final answer of around 20.8. And what are the units? Joules per kilogram degrees Celsius. Okay, so that is the specific heat capacity of our mystery material in our question. So hopefully that made sense. Hopefully you got that correct. And I'll see you in the next video.